So I'm going to show you a third law demonstration. We've got a holder here, which is about 5 grams. We've got two 100-gram masses, two 20-gram masses, and a 10-gram mass. So I basically have 255 grams worth of material here. So if we converted that into newtons, that would be roughly 2.5 newtons. And I am going to hook that mass up to a system here. I've got a track with 2 pulleys. However, on this side, the string is not attached to the pulley. It's just underneath there. I've got a force meter, which is basically reading 0. I guess I could like adjust it a little bit. And then over here, I've got my massless string going over top of a pulley. And I am going to take my masses here and hook them up. So now the question for you is, what is the spring scale going to read? Well, if you said that it would read about 2.5 newtons, you are correct. The spring scales are a little fishy. Let's see. Yeah, we're right about 2.5-ish. So, like, they're old, but we're getting data that's relatively decent. Okay, now, I've got another set of weights here. Again, the holder with a 100-gram weight. So let's flip that over so you can see 100-gram weight there. And then, boom, I've got 3 50-gram weights here. So again, I've got 255 grams of mass that I'm gonna come over and hang on the far side there. So instead of having one string that goes to a force meter, which goes to basically a wall, I'm gonna have another string over here that goes to a pulley and hangs over. I'll show you what I mean. So I'm taking my weights. I am going to find my long string, which is right here, and I'm gonna disconnect this guy from the thing and turn my pulley. Now I'm gonna hook up my string, hang it over top here, and then I'm gonna hang this string over the top. Okay, so you can tell that the weights are basically even because when I move this thing, it almost travels at a constant speed with no friction, though there is a little bit of friction. So what do you figure the scale's gonna read? Last time I had 250 grams or 2.5 newtons hanging off this side attached to a wall. But this time I have 510 grams, 255 on each side, or 5 total newtons hanging off the side. What's the scale gonna read? Take a guess. If you guessed that it would read basically 2.5 newtons, you're a pretty good physics student. What's going on there? I thought that we would need the scale to read 5 newtons. You would think, because now I have 5 newtons of force on there. But here's the deal. Before, when I held the string right here, so forget that weight, I'm holding it. My hand has to provide the force to keep this thing from moving. Okay. I can't allow this to move. So if there's a 2.5 Newton force going this direction, I need a 2.5 Newton force also pulling the opposite direction provided by my finger. When I let go, Now it's not my finger providing that force, it is the other mass, the other weight that is providing that force. Third law, people. It's easy to state, but it's not always easy to understand.